So to continue with an example, you have a 5 kg ball that's being dropped, and we find that it has an acceleration of negative 8.4 meters per second squared. Meaning a ball was dropped, and we measured the acceleration, and it turned out to be negative 8.4 meters per second squared. Now, normally, it should be 9.8 on Earth, but we have some air resistance because of which the acceleration is not as high. And so our key is to go ahead and figure out what is going to be our force of air resistance. And so you know that there was no air resistance. It should have been just simply 9.8, but negative 9.8, but it's not in this case. So again, we go ahead and write that equation that we had up here earlier in our previous video, which was simply F air. Again, this is the object, that's F air, and that's Fg, and those are the only two forces. So F air minus Fg equals ma. And so we rewrote that as F air minus mg equals ma. And so now we're looking for the force of air resistance. And if you really look, we have everything else given to us. The F air would then equal to minus 5 times 9.8 is equal to the mass of the ball again, which is 5 kg, times negative 8.4 meters per second squared. And so all we do is chunk in the numbers. 5 times 9.8 would be 49 is equal, F air minus 49 is equal to 5 times, that's